What should we pay attention to when maintaining wire drawing dies? Hi everyone, I'm Penny. Lately, quite a few of my friends in the wire and cable production industry have come to me with a common frustration. Penny, why have our copper wires been breaking so often recently? Sometimes the surface even peels or gets scratched. What on earth is going wrong? Whenever I hear this, my first instinct is to tell them to go check the heart of their production line, the wire drawing die. And just as I suspected, when they removed the problematic dies, the sight was often alarming. In many cases, the entrance of the die was clogged with shiny copper shavings, which is like an alarm bell telling us that severe wear has occurred inside. Many people may not realize that the internal profile of a small drawing die is a precision-engineered design. We usually need to pay attention to several core areas, with the most critical being the lubrication zone and the compression zone. A die in good condition typically has a lubrication zone angle of around 50 degrees, ensuring that lubricant is smoothly drawn in. The compression zone, which is where the copper wire is actually reduced in diameter, has an angle controlled between 12 and 16 degrees. This angle is key to achieving smooth compression and minimizing friction. However, during the high-intensity drawing process day after day, wear will quietly happen if we neglect maintenance. The most typical situation I've seen is the compression zone becoming severely worn down from constant friction, causing its bore size to exceed design tolerances. Even more critically, its working angle gradually gets ground down, becoming much larger than the 16-degree upper limit. When the angle of the compression zone becomes too large, it begins to encroach upon the territory of the lubrication zone. This destroys the entire lubrication mechanism. The lubricant can no longer form an effective protective film under high pressure, leading to what is essentially hard-on hard dry friction between the metal wire and the die. Under these conditions, the drawing resistance increases dramatically and the tension on the copper wire far exceeds its limit, ultimately causing it to break. At the same time, the heat generated by the intense friction can soften the surface of the copper wire, causing it to adhere to the die and then get scraped off by the wire that follows. This is what we see as peeling or scratching. So, the next time you encounter a similar problem, you might want to do as I suggest and take a closer look at your dies. The problem often isn't with the copper wire itself, but with whether we've given these precision tools the attention and maintenance they deserve. Timely maintenance not only prevents wire breakage, but is also fundamental to ensuring product quality and production efficiency.